Hi, so I'll be making a video about problem 1 on problem set 5, the merry-go-round problem. Drawn a little illustration here. So the first thing I did when I read the problem was draw a picture with the data that I was given. So the problem states that a child sits on a fiberglass goose fastened 6.3 meters from the center of a merry-go-round platform, rotating every 10 seconds. So it wants to know the speed, the acceleration, and also the child's acceleration if the radius changes to 5.2 meters. So by drawing this picture, I was able to see that the circumference is equal to the 10 seconds, and then the radius here is equal to 6.3 meters. So drawing that illustration kind of helped me figure out what values to plug into these formulas. So for part A, calculating the speed, I used the formula for velocity, so 2 pi times the radius over time. So I calculated 3.96 meters per second by plugging in that 6.3 radius and that 10 seconds for the time. For B, acceleration, all you're going to do is square the velocity. So the acceleration is the velocity squared. So all I did was basically square the values in this formula. So 4 pi r over time squared, which was equal to 2.49 meters per second. In the last part of the problem, you basically, for part C, are just repeating part B. It's asking for acceleration again, but with a radius of 5.2 instead of 6.3. So I used the same formula, plugged in the 5.2 for the 6.3, and got an answer of 2.05 meters per second squared. So the problem is fairly simple if you just follow the formulas and plug it in.